Welcome to part 2 of Unit 4, talking about percents. We're going to do a lot of application problems in this part. Since there's so much material in this section, I highly recommend that you print out the PowerPoints and the notes that I'm going through here in the video and make your own notes on them, write on them. And also, I highly encourage fast forwarding. So going through the notes and only listening or watching the parts that you don't understand will save you a lot of time. I know the first video was almost a half an hour, and this one is likely to be as long. So as a reminder, percent problems include three parts: the percent, the part, and the whole. And so what we're going to look at now is word problems. But if in each of those word problems you can figure out what the percent is, what the part is, and what the whole is, it will make the problem much easier. So I didn't talk about this before, but a very useful tool in solving for percent problems is using what's called a proportion. So anytime you have a fraction equal to another fraction, it's a proportion. And you'll notice up here I have these fractions where I say the part over the whole is equal to the part over the whole. So you can always do that with any sort of word problem ever where you're given information where you've got a part and a whole, or relationships where you know 3 out of the 4 pieces. A lot of times you can write them as two fractions equal to each other and solve for the unknown piece. So for example, here's a very simple example. 2 is to 3 like what? Like 24 is to what? So the word like is equals. And when I say 2 is to 3, that is a fraction. 2 divided by 3 is the same as 24 divided by what? And remember, that what is the thing that we don't know, what we're looking for. So if I write that as a proportion, I have 2 over 3 equals 24 over question mark. And there's two ways to solve these problems. I'm going to show you the way that always works, and then I'm going to show you a shortcut that is much easier if for the special cases where it works. Okay, so we solve these problems by doing something called cross multiplying. So I'm going to multiply the two things that are on a diagonal together. So I would take the 2 and I'd multiply it by the question mark, and then I keep my equal sign, and then I go in and I multiply the other 2. So I come over here and I multiply along the other diagonal, and so 2 times question mark equals 3 times 24. And then we can go ahead and do 3 times 24 on our calculator. So I come over to my calculator and I type 3 times 24. And I get 72. So I know that 3 times 24 is 72. So 2 times question mark is 72. Now you'll remember from the previous video, if I have 2 times something that's unknown and I want to know what that question mark is, I would go and I would take 72 and I divide it by the thing that's multiplying the question mark. So I know my unknown is equal to 72 divided by 2. So I type that into my calculator. I already have 72 on there, so I just hit divided by 2 and I get 36. So I know that 36 is my answer. So I go back up here. 2 is to 3 like 24 is to 36. So that's how to solve this problem. We set it up as two fractions with an equal sign between them. We cross multiply. We multiply the side that has both numbers, and then we divide by the thing that's multiplying the question mark. Now the shortcut is if you can tell that the two numbers directly across from each other are two things that I would multiply together evenly. So 2 times what is 24? Now if you can figure that out in your head, that's really useful. So I know 2 times 12 is 24. If you're not sure, you would just, again, we do the division. 24 divided by 2, that's 12. So since they go in evenly together, since 2 times 12 is 24, with fractions, as long as I multiply the top and the bottom by the same number, I don't change them. So if I multiply the top by 12, all I have to do is multiply the bottom by 12 to get my question mark. So my question mark is 3 times 12. So I do 3 times 12, which is 36. So this is a shortcut to work with proportions. Now, granted, many of them are not this simple, but it's being able to set up the proportion problem is a big step in the right direction to solving percent word problems. Now we're going to do some more complicated problems involving percents. Okay, let's start with a tax problem. So first thing when you see these word problems, you want to read it all the way through, and if you can place yourself in the scenario, it really helps solve the problem. So for the first example, Ace Hardware sold $78.37 worth of supplies to a customer. If the sales tax is 5.5%, what was the checkout price? Now, you can think about this in your real life and say, how do I figure this out? And that might help you set up the problem. But if you can't, what you want to do is you want to figure out the percent, the part, and the whole. So I have numbers here. I have 78.37, and I have a sales tax of 5.5%. Now the 5.5 is obviously my percent, and what I want to know is the 78.37 the part or the whole? And it kind of depends on how you look at it, but for the way I'm going to do this example, this is the whole. So I want to know what the part is. Now remember, when we were doing these calculations the previous time, we were decoding them. Remember, it's always of the whole times the whole. And so we can continue to do it that way. But now that you know what proportions are, if you want, you can also write it as a proportion where you put a question mark for your unknown piece. So I'm going to continue to do it the way I did in the last presentation for you. So we want to do the sales tax as a decimal. So remember, we want to move our decimal 2 places to the left. So I have to add a 0 right there. So I take 0.055 and I multiply that times the whole, 78.37. And I try and figure out what does that equal. So I need to get my calculator out and figure that out. Okay, well, my drawing tool decided to erase itself. So I just went in and typed in the numbers I had. 0.055 times 78.37. We're going to do that calculation. 0.055 times 78.37. And I get as an answer 4.31. So that means my question mark is equal to, this is money, so I'm going to round to the nearest penny, 4.31. Now, the question is, what did I just find out? Did I figure out what the checkout price was? And the answer to that is no, I didn't calculate the checkout price. So what did I calculate? I found 5.5% of $78.37. So I found what the actual sales tax is. I found the sales tax. But I want to know what the checkout price is. And the checkout price is equal to the sales tax plus the list price. So I just take the sales tax, I add the list price to it, and I will get my checkout price. So that means I'm going to take 78.37 and I'm going to add $4.31 to it. So that's going to give me my checkout price. So 78.37 plus 4.31. So my checkout price as a decimal is $82.68. That's the checkout price. And that's the answer to the question. Make sure when you do these questions, you answer the question being asked, and you always include units for every single one of these word problems. Also make sure you round it to the appropriate place. On every problem I tell you, in the practice and the quiz and the quizzes and the test, I tell you to how many decimal places you need to round, and you will get it wrong if you do not round correctly. Okay, that's the first one. So the second one is about a production run of steel pins. Let me hide the calculator so that we can read the whole production run of steel pins is estimated at $3.275. So it goes to the nearest half penny. Material cost is estimated as 35% of the total cost. What is the estimated material cost to the nearest dollar? I'm going to draw on this so that I can actually, maybe I'll just highlight some of this stuff. So what we need here is, again, we need to identify what is the part and what is the whole and what is the percent. So if you can figure out how to rephrase the question so that it's really basic, then sometimes that helps you, because there's a lot of extra words in word problems. So production run of steel pins is estimated at $3.275. So I'm just going to underline that. And then the material cost is estimated as 35% of the total cost. 35% of the total cost. What is the material cost? So you have to read this and think about it. The material cost, is that the part or the whole? And since the material cost is estimated as 35% of the total cost, I know that material cost is my part, which makes the estimate, the 3.275, is the whole, and 35% is my percent. So we're going to convert the 35% into a decimal, 0.35. We're going to multiply that by the whole, 3.275, and that has to equal the part, which is the material cost. Okay, so now we're going to run in and use the calculator on this. So I type 0.35 times 3.275, and I hit equals, and I change it to a decimal, and it's 1.14625. Now, I ask you, as soon as you see these big numbers, you should reread the problem to see how you have to round it. It says, I want to round it to the nearest dollar. Excuse me, the nearest dollar. So I would round this to $1. So I come back in here and I say that the material cost is $1. It's rounded from 1.14625, but that's what they asked me to do. It says round it to the nearest dollar. Okay, let's move on to example 3. Okay, an inspector rejects 23 out of a total production of 630 electrical switches. What percent of the total production is rejected? So this one is very close to being straight forward, where you can just directly translate it, because I have 23 out of a total. They tell you the total is 630. So I know 630 is my whole. So that's the whole, which means that 23 is my part, and I don't know my percent. So my percent times the whole is equal to the part. The whole is 630, and that equals the part. Now remember, when we do this, since I have a question mark times 630, if I want to know the question mark, I do 23 divided by 630. And you can use the division symbol. You can also use the backslash, which some calculators use for division. And so notice it kind of looks like a fraction, because division and are the same thing. Okay, so let's do that on the calculator really quickly. So 23 divided by 630. And remember, when we write it as an equation like this, the percent always shows up as a decimal or a fraction. So here is my decimal. It's the question mark, which is my percent, is equal to 0.0365. Now I'm going to say 0.7 9. I'll stop there. Okay, so next thing we have to do is change it to a percent. So we change it to a percent by moving the decimal point 2 places to the right, which is the same as multiplying by 100. So I multiply by 100, and as a decimal, I get as a percent, I get 3.65079. Now I go back and I read what it says, and it says round the answer to 1 decimal place. So as a percent, I want to round it to 1 decimal place. So that's 3 point, and since the second decimal place is a 5, I know I'm going to round up. So it's 3.7%. So 3.7% of the parts are rejected, which I have to say is very high. If you're making that many mistakes, there is something wrong with your production line. Okay, let's move on to example 4. A motor is said to be 80% efficient if the output is 80% of the input. How many horsepower does a motor receive if it is 80% efficient with an output of 6.20 horsepower? HP stands for horsepower. Now it says that the output is 80% of the input. Now remember, it's always of the whole, which means that your input is the whole and the output is the part. So I know my percent, I know my part, and I'm looking for the whole. So when I set up my equation, let's do that now. I have 80% as a decimal, which is 0.8 times the whole, which I don't know, is equal to the part, which is 6.20 horsepower. Now hopefully you printed this problem out, so the fact that I'm covering up a piece of it doesn't matter so much. Now remember, I want to know the question mark, so I take my 6.2 and I divide it by the thing that's multiplying. So 6.2 divided by 0.8 is going to give me the input. It's going to give me the whole. 6.2 divided by 0.8. So as a decimal, that's 7.75. So my input, the question mark, which is my input, is equal to 7.75 horsepower. So the next problem involves percent error. So how much was a mistake written as a percent? And you can see that I show how to write it using a proportion, and we're going to do an example with it. So again, let me hide the calculator and then we'll get started. So I want to figure out the percent error, and so that means I have some sort of a measurement that something is supposed to be, and I make a mistake and I'm off by a certain amount, and that's my percent error. So say I want to cut a piece of wood, I accidentally make it 1 inch longer than it's supposed to be. If it was supposed to be 9 inches, the amount off, my percent error, can be written as a percent. And so what I do is I write a proportion like I show here, or I write the equation, but I'm going to show you the example with the proportion, and we'll do that calculation. I'm actually going to draw this one. So let's see, I'll go ahead and, okay, so I don't know the percent error. That's what I'm looking for, and it's out of 100. My amount off is 1, and it's supposed to be 9. So I do 1 divided by 9 is equal to question mark over 100. Now we can cross multiply here, but when I have the percent as my unknown, this is the same as saying that my unknown is equal to my fraction, 1 divided by 9, and I multiply my fraction by 100 to get it as a percent. I want this fraction converted to a percent. So when you plug it into your calculator, you get 100 divided by 9, and that ends up being 11.1%.